This is Farzan Tairi from the Animal Science Department. The information that I want to share is the effect of parsley powder as a source of nitrate on some quality characteristics of uncured fermented sausage. Recently, there is a wide variation of fermented meat products which differ in the start-to-culture type and ingredients. These ingredients include, but not limited to, the start-to-culture bacteria, salt, sodium nitrite, and dextrose. In 2002, Finderstop stated that using sodium nitrite enhanced color and flavor, reduce lipid oxidation, and inhibit the microorganisms' growth. However, in 2011, Alexander and his colleague reported that some studies showed a potential relation between nitrite, and N-nitrosis compound and the risk of human cancer that increased the demand for uncured meat products. As a result, the use of vegetable powder or eliminating of sodium nitrite may lead to change in the product properties. So, the objective of this study to determine the effect of parsley powder as a source of nitrate in fermentation and color in uncured fermented sausage. In the material and method, we use the basic formulation for fermented sausage. The test ingredients were included lactic acid bacteria and nitrite for control products LN. SP treatment had Staphylococcus carnosus bacteria with parsley powder. SLP treatment had Staphylococcus carnosus and lactic acid bacteria with parsley powder. SL treatment had Staphylococcus carnosus and lactic acid bacteria without any addition of parsley powder or nitrite. Finally, S treatment had Staphylococcus carnosus bacteria alone. After mixing the ingredients, 50 grams from sausage were taken and incubated for 24 hours at 40 Celsius to mimic the meat processing fermentation. The pH was recorded every 6 hours by pH meter. The lightness L, redness A, yellowness B were taken at a random location in sausage for all treatment using colorimeter CR300. The color was measured after incubation, 7 and 21 days of storage at 4 Celsius. In the result, figure 4 shows the effect of parsley powder in lactic acid formation in fermented sausage. The x-axis has the time by hour, y-axis shows the pH value. The initial pH for all treatment were about 5.6. There was no difference between the treatment at 0 and 6 hours. After 12 hours, there was a significant decline in the pH value in the treatments that inoculated with lactic acid bacteria. These treatments included control, SLP, and SL that behave continue until 24 hours. After 24 hours, the highest pH was absorbed in S and SP treatments, which was about 5.25. The control and SLP treatment were at 4.73. Finally, the lowest pH was showed in S treatment, which did not include any parsley powder or nitrite. Table 1 shows the effect of parsley powder in color, lightness L, and redness A in fermented sausage. The data for yellowness P did not show because there was no difference between treatments except S. In the lightness L, the greatest value were showed in control and SL treatments from after incubation until the end of the experiment. In the redness A, after incubation there was no difference between control and S treatments, and between SP and SLP treatments. Moreover, the S showed the lowest redness value. After 7 days, there was a sharp decline in the redness for S treatments. After 21 days, there was no difference between control and SLP treatments. In conclusion, parsley powder with Staphylococcus carnosus and lactic acid bacteria give a similar pH and color stability to the products made with nitrite. parsley powder may be a suitable ingredient for the manufacture of certain uncured fermented meat products. Our plan for future research: study the effect of parsley powder in palatability, determine the effect of nitrite reductase bacteria on fatty acid profile, investigate the effect of parsley powder and nitrate reductase bacteria in lipid oxidation.